All right, to find the definite integral using the limit process, we need to find the limit as n approaches infinity of the sum of f of x sub I times delta x. So our delta x in this case is going to be 1 over n because it's the upper and lower limit, so 1 minus 0 over n, and our x sub I is 0, the lower limit, plus delta x then times I, so it should just be I over n. Now, we'll plug this I over n everywhere there's an x in the formula there. So what it's going to end up being is it's the sum of negative 2I over n plus 3, and then all of this being taken times 1 over n. Okay, I'll distribute the 1 over n through and then separate out the summations. So then this should equal the sum of negative 2I over n to the second plus 3 over n. All right, now the sum of I is, so let me get this down. So the sum of I then is n times n plus 1 all over 2 plus 3 over n, and then times the sum of that should just be n. Okay, so the n's will cancel there. This n will cancel one of those, and that 2 cancels that 2. So then I should end up with negative n minus 1 all over n, and then just plus 3. Okay, now doing the limit process here, that one will disappear, and then this fraction here should just become negative 1 plus 3, which is positive 2. So that should be a 2. Now, if we look down here to these lower two examples, just the indefinite integral process here, if I just add 1 to every power and then divide by the new powers, I should get 2x to the third over 3 plus x squared over 2, and then minus x plus c. No big deal. Now the bottom one, like I showed earlier, I think it's easier if I were to rewrite this as 2 over the square root of 3 over, and then like that, so it's just the square root of x. So then it makes it a little easier, so I don't have to do a u substitution. Now I'm going to slide the numbers out in front, so it's 2 over the square root of 3, and then it's the integral of bringing the square root up to the top, should be x to the negative 1/2 power dx, and then just follow the power rule for integration, 2 square root of 3, and then it's x to the 1/2 now if I add 1 to the power divided by 1/2 plus c. Flipping this fraction, or find the reciprocal of that fraction, 1/2, or dividing by 1/2 is the same as timesing by 2, so I should end up with 4 over the square root of 3, and then times x to the 1/2 plus c. Okay, let's look at number 4 now. Number 4, again, is just kind of the chain, or is just kind of a basic integration. Now, because these are trig ones, you will want to look them up off the chart, but the integral of cosine is just the sine of x. Well, and since there's a 5 out in front, we'll just keep the 5 there. And now this one, this is the one where you think you got to do a lot more, but remember, again, look these up off the table because they're there. The integral of secant squared of x is tangent x, and then it's just plus c. Okay, now let's look at number 5. Number 5 says the integral of x squared and then square root of x cubed plus 3. Let's let u equal the inside, because if I have a variable multiplied by something else, I can't do any type of product rule for integration. So let's let u be the thing under the radical, which means then du is equal to 3x squared dx, right? So I've got a dx, I've got an x squared, so I'm missing a 3. So let's put a 1/3 out in front to account for that. And then so we'll have 1/3, the integral of, substitute everything out, I have u to the 1/2 du. So then that'll equal 1/3. Power rule says u to the 3/2, so 3 over 3/2 plus c. Okay, reciprocal of the fraction should give me 2 over 9, and then substitute back in, we should end up with x cubed plus 3 to the 3/2 power, all plus c. Okay, let's look at some of these more down here on the bottom. Let's look at 6 and 7. Number 6, let's see. This one does take a u substitution. So I see that I have sine cubed. So let's just let sine of x be u. The derivative then of sine of x is cosine of x dx. Well, it turns out that I have exactly that. So we'll just say that it's now the sine of, or excuse me, the integral of, well, instead of sine cubed, let's just say it's u cubed. du. Power rule says u to the 4th over 4 plus c. Substituting sine back in, I should end up with sine to the 4th x over 4 plus c. And the bottom one down here, again, is a u substitution, so u is equal to x squared minus 1. And we'll go du is equal to 2x. So I have everything, 2x dx. So I have everything I need, so then that just means that I have the integral of u to the 3rd du. Well, the power rule says that that would be u to the 4th over 4 plus c. So then I should have x squared minus 1 to the 4th all over 4 plus c. Okay, looking at page 3 now, 8, 9, and 10. So for looking at number 8, let's let u be the inside again. So that would be 4x to the 2nd plus 3. And so then du is equal to 8x. Okay, well, I don't have an 8, but I do have an x. So I don't have to account for that. So let's just put the 1/8 out in front, and then we should be okay. So it's 1/8 the integral of u to the 3rd du. And the integral of u to the 3rd should be u to the 4th over 4, remembering that there's the 1/8 out in front, so plus c, which means my final answer should be 1 over 32, and then 4x squared plus 3, all to the 4th, plus c. Like that. Okay, number 9, the one that is not a real great problem, because if you let u be 2x, or x plus 2, du is just 1 dx. Okay, well, we have the dx, but we've got that there, which is not good for us. So that means we need to substitute for x as well as that. Well, x equals then u minus 2. Okay, so now we should have everything accounted for. So we'll take this, and it goes there. This will go here, and that will replace, or this here will replace that. So now, rewriting this, since I have lines everywhere, should be, I have the integral of u minus 2 times, instead of x plus 2, I have u, and then to the 1/2, du. Okay, distribute. So I have the integral of u to the 3/2, that's a 3, minus 2u to the 1/2 du. Now we do the integration. U to the 3/2 becomes u to the 5/2 over 5/2 minus 2u to the 3/2 over 3/2, all plus c. I'm not going to do any combining the term or finding a common fraction, so I have 2/5 times x plus 2 to the 5/2 minus 4/3 times x plus 2 to the 3/2, all plus c. So sorry, that kind of got jammed up in there. Okay, and now let's look at the bottom one down here. All right, find the area under the region bounded by this formula. So what it's asking is, this is the word problem form of how to do a definite integral. So you're going from the lower limit of -1 and up to 3, and then this is the function that you're going to use here. So now we'll use the fundamental theorem of calculus, which says just find the integral and then just plug in the upper and lower limits. So the integral of x to the 3rd is x to the 4th over 4, and then we'll plug in 1 and 3. So if I plug in a 3, I should get 3 to the 4th over 4 minus 1 to the 4th over 4. 3 to the 4th should be 81 over 4 minus 1 over 4. So I should get, 80 over 4 then? So that should come out to 20.